The presenter is Fabiano Gamberi, talking about plunge pools and beyond, the influence of slope breaks in deep sea sedimentary processes. Go ahead, Fabiano.
So, okay, and so plunge pools were first discovered in 2002 by Lee, and they were discovered in the Californian and New Jersey margin, and they were described as small oval or circular depression at the base of the continental slope. The author suggested that they formed due to hydraulic jumps or due to impact pool in slope break with value more than 4 degrees. Following this first finding, plunge pools have been discovered in many other settings, both carbonate and siliciclastic. And one important thing is that they have been recognized as one of the settings that can be found at the channel mouth setting. They are also being described in canyon mouth. And these findings have shown that they can form in breaks that are much lower than what was thought at the beginning by Lee et al., because they form in slope break that are about 2 degrees. And to further investigate the issue of plunge pool formation, I have analyzed data on the Tyrrhenian Sea, which is a good site for their exploration because it is a very complex slope setting. And we have, in fact, a passive margin along the Sardinian area with large intraslope basin and horst graben. And then on the Campanian margin, we have, on the contrary, a stepped margin with narrow terraces separated by steep fault-controlled escarpment. In the Tyrrhenian Sea, we have recognized 3 main types of plunge pools on the basis of their morphology, their location, and their associated depositional and erosional feature. In the following, I will describe these 3 types of plunge pool, and I will try to suggest some processes that can give rise to their origin and what they imply for the surrounding deep sea environment. So in the Tyrrhenian Sea, the plunge pools are found along canyon course at the canyon mouth, channel mouth, and levee wedge. They are also found along step in extensional graben basin. They are found along complex sedimentary pathway at the base of slope in open slope without any canyon, at the base of slope where we have a landslide complex, and at canyon mouth not connected with the shelf. So now I'm going to describe the different type, and I will start with the type 1 plunge pool. These are mainly erosional features. So you see these depressions. So in here, the different colors are spaced at 2 meters. And you see the corresponding profile in here. So you see this depression, and this is the elevated area, but everything is as a negative relief with respect to the surrounding seafloor. So it is interpreted as an erosional feature. And you see that it is located at the base of this escarpment connected with the canyon. You see also that in the plunge pool, we can see an accessory smaller scale feature that can be scours. And this is connected to an area of widespread erosion in this area in here. Another example of erosional feature is this one. In here we have a row of 3 plunge pools. You can see the all in here, in there, and in there. These are located at the base of this escarpment, are connected to this canyon, And they are in an area where we have different steps and terraces, which are bounded by these folds, which are indicated by these white lines. And you see that in the profile, I have interpreted that each of these terraces forms its own plunge pool here, in there, and in there. These plunge pools are very deep. They are about 85 meters deep, and they have a considerable length. You see, these are 4 kilometers, so these are about 5 to 6 kilometers in length. And you see that these sit within this larger scale erosional area. So to interpret these, I think that we can think about net erosional scours or cyclic steps, and this is what they are like. So this can give rise to a single plunge pool, like in the first case, or to a row of plunge pools, like in the last case. And you see that in this scheme, I have put them within a large erosional area, and I think these can show us the way in which canyon are initiated, and this pose also question on the initial infill of canyon above the erosional surface. This is an example of this undulating erosional surface with a field that therefore can give rise to separated depositional bodies in the lower part of the canyon infill. So these suggest us that maybe a mechanism similar to what has been envisaged by Daniel for nick points can be played by plunge pool at the beginning of canyon or channel inception. We pass to the second example of second type of plunge pool. You see, these are smaller scale features. They are in the order of 500 meters long and 4 to 5 meters, 15 meters deep. You see, these are the transversal profile, and the important thing is that these one are followed downslope by this flat area. You see these in the profile, which correspond to this area with the homogeneous color in the map. These are located at the canyon mouth, and you see that they are not really at the canyon mouth, but they are still confined within the canyon. Further downslope, these pass to levee channel that you can see in this transversal profile along this yellow line. You see the channel and the equivalent levee. So to interpret the genetic processes of this type of plunge pool, I have looked at the laboratory experiment of Hamilton et al. On supercritical distributary channel and depositional lobe, and these authors have shown that after a progradational phase, we have a stagnation phase in which we build this topography, and this topography induced the formation of an hydraulic jump and the formation of a scour. I think that this scour is maybe what we see in our data, the plunge pool, and you see that the plunge pool is then infilled by this back set of strata, and this is what they obtained with their flow modeling. And I think that if we look at the data that were obtained by McDonald, these can give us the detail of what is this back stepping unit, and maybe these are unit bar formed by the hydraulic jump, and you see that they can form long unit bar, or they can form a series of backstepping unit bars, and these can also give rise to a second jump downslope. So I interpret this type of plunge pool as corresponding to this setting, and I think that this can give us important insight into the infilling of a gradient basin, and this is an example from the grade Peira Cava, and you see that Emi et al. Interpreted this backstepping amalgamated sandstone formed in this proximal cut and fill zone that I think can correspond to the area of the mouth bar and of the plunge pool in our data. So we can go to the third type of plunge pool, and you see that in this case we have again a very big structure. They are as deep as 100 meter, and the downslope from this plunge pool that you see is located again at the base of this escarpment fed by this canyon. You see that we have the development of this extensive field of bedfonds. And this is a dipping area. The dipping area is 1.62 degrees, so it's not very steep. And I think this is a depositional area, and I interpret this as a fan. And if you look at another type of what I call 3B plunge pool, again, we have these plunge pools which are at the base of this steep escarpment. And in this case, these are connected not with a fan, but with an erosional area. But still, you see that in the proximity of the plunge pool, you have this depositional area highlighted by this yellow and green color. And you see that this is the longitudinal transversal profile along this series of plunge pool, which are this one. And you see that we have the plunge pool and this depositional area. And these depositional area are breached in their frontal area, in this area here and in there. So I think that in here, this depositional area, which is directly associated with the plunge pool, pass downslope to an erosional area, and this is explained by the high dip of this area, which is 5 degrees. If you remember, the previous one had just a dip of 1.62.
2 minutes.
So to interpret this setting, I have looked at the data by Lang et al. Again, a laboratory experiment in which they have shown the formation of this scour that can be interpreted as the equivalent of our plunge pool, and this mouth bar followed downslope by this large field of sediment wave. And this is mainly due to the passage from the momentum dominated to the gravity dominated flows further downslope. So to interpret this last kind of plunge pool, I think that we have two types. More importantly, in the first type, in the 3A, we have the formation of a proper fan, and this fan is as its proximal part, which is occupied by a plunge pool. Then we have a mouth bar, and then we have a fan which is characterized by the extensive development of sediment waves. In the other case, on the contrary, because of the gradient of the terrace or basin, we have that the mouth bar pass directly to bypass or erosional area. This one also has its equivalent on the field, and this one is an example from Bouma et al. 2021, where we see the channel, we see this erosional area that can correspond to the plunge pool, we have the mouth bar, and we have this field of sediment waves further ahead from the mouth bar. So I come to the conclusion, and this study shows that the plunge pool can have a variety of morphologies that can be indicative of different genetic processes. They are important and frequent elements of topographically complex slope, and I would add that that can be a very important element that controls the deposition in the deep water, both in canyon and in fan. They can be precursor of canyons. Plunge pools and mouth bar pairs can represent one of the configuration of canyon channel mouth, and they are important. In fact, they can contribute to the backfilling architecture of canyon and channel. These during the phase of basin aggradation and system retrogradation. And they can be an important part of supercritical fans, and these can furnish good analogs for small-scale radial fans on steep, topographically complex margin. Okay. That's all. Thank you for the attention. I hope that everything was working well.
It was working very well, and thank you very much, Fabiano, for this presentation. That really is a step upwards in the documentation of plunge pools. It's very good overview. We have a question coming from the audience by Erlanga Septama. Very interesting features. Is there any significant distinction that can tell the difference between a plunge pool and a common channel, either in the erosional base or the internal architecture or internal sedimentary succession?
So I would say that if you look at the erosional phase, so the erosional type of features, I would say that the difference are very smooth, because I think there's a passage between the plunge pool and a really formed canyon. If you look at this image in there, which is the type 1, you see that this plunge pool, in my opinion, if they evolve to a full stage, they will give rise to a canyon first and maybe a channel. But in any case, they will be an inherent part of a channel or a canyon. So I think that the distinction is just a matter of time. So
Okay.
in time, plunge pool will evolve to canyon or channel.
Well, that poses some really interesting challenges for finding these in ancient stratigraphic records as well. I guess that's really fascinating.
Yeah, because you first have to find a longitudinal section. So I think that what Daniel has shown before has a meaning also for these issue, because in that case we talk about nick point, but a nick point in many cases is followed downslope by a plunge pool. So I think that the process is more or less the same. Maybe the scale is a little bit different. I didn't have talk about plunge pool developing within the canyon and channel of the Tyrrhenian Sea, because that will open a big issue, because every channel that you look at, particularly in the active area, is completely formed by these small scale plunge pool. And another issue is that plunge pool can be also very similar to scour, so there's maybe also a terminology issue.
Looking forward to how it proceeds. So